All right, what do you all think? Do you think we should go for it? All right. Okay. Well, good evening, everybody, and thank you so much for joining us tonight. We've been really excited about sharing some of this information with you tonight. Um, it's going to be I think a really interesting webinar. And yeah, I think to start off with, though, I think it'd be nice for the panelists to introduce themselves, and maybe we could start with you, Grace.
Sure. Hi, everybody. Thanks again for joining us. My name is Grace Bear. I've been working with BC Whales and the North Coast Cetacean Society for about 5 years now. This has primarily been out in the field on Finn Island, which you'll hear a little bit more about shortly. And I'd also just like to recognize that I am speaking to you today from the traditional and unceded territories of the Coast Salish peoples, including the Tsleil-Waututh, Coquitlam, Squamish, and Musqueam nations.
Ben?
Yes. Hello, everybody. It's great to be here. It's great to see so many people tonight in the audience. Very excited to speak tonight and listen to your questions afterwards. My name is Ben Hendricks. I'm a software engineer and acoustic analyst with Soundspace Analytics. And I'm working since 7 or 8 years now with Janie to better understand whales and work towards a balanced ocean. And I live in the Comox Valley, which is also the home and the traditional territory of the Comox First Nation. Tom.
Hi, everyone, and welcome. And I'm speaking to you from the Wasanich First Nations territory. My name's Tom Dakin, and I'm the science officer at Sea to Shore Systems. And personally, I've been working with Janie's group since about 2013, I guess. And recently with Sea to Shore Systems, we've been supporting the BC Coastwide Hydrophone Network for a little over 3 years now. And our company's been doing the design of the acoustic systems and the installation and maintenance of them for the past 3 years.
All right. Well, thanks, everybody. And yeah, I just want to say that the work that we're doing wouldn't be possible without the panelists and the people that are going to be speaking to you today. So I'm extremely grateful that you're all here today. I'll just go over a little bit of housekeeping. As you can tell, we ask that you keep your camera off and your microphone muted while we go through the presentations. But do feel free to put any questions in the Q&A as we go through the presentations. We will wait till the end of the last presentation before we go through the questions. And we're all hoping that there'll be plenty, because we're very keen to participate afterwards as well, and to hear your feedback at the end of this. I should also introduce myself. My name is Janie Ray, and I'm the CEO of the North Coast Cetacean Society. And I've been studying the acoustic behavior and tradition and culture of whales now for over 20 years. And I am speaking to you today from the unceded traditional territory of the Namgis First Nation. And I think it's time to get started. So with that, I'm just going to start off with a little bit of background about BC Whales. We're actually supported by the North Coast Cetacean Society, and our work started over 20 years ago. We actually traveled up the coast of BC in a very small liveaboard and arrived in the First Nations village of Hartley Bay, and that was back in 2001. And at that time, we actually spoke with the hereditary chief, Johnny Clifton, and his wife, Helen, and the entire community. And we asked for permission to build a whale research station within their territory. And not only did they give us permission, but they also shared with us their local knowledge of whales. And so the work that we're presenting here tonight would not have been possible without their support. And then in 2016, we actually built a second research station in Gitga'at territory on Finn Island. And our research methods from that station are very focused on non-invasive, conservation-minded projects. And these include acoustic monitoring of whales, land-based and marine surveys, and recently the use of a drone, which really was like opening up Pandora's box. And we've combined these techniques to help us to better understand the culture and acoustic tradition of whales and the potential impacts of vessels and other human activities, which is what we're going to be speaking to all of you about tonight. Just to give you an idea of the location, the Finn Island Research Station, which is in Gitga'at territory, is up near Hartley Bay in this area along the north coast of British Columbia. And this is just zooming in here. So that tiny little island right there is Finn Island. And this is just zoomed in a little bit further so you can see the actual island, which is right here. So the station is located right on the south end of the island. And this is just to give you an idea as to how remote we are. We're actually right in the middle of the Great Bear Rainforest, which is absolutely gorgeous. And I'm sure many of you have been there. And as you can see, this island is remote. There are no roads. There are no other people on this island. It is just the research station, ourselves, and the whales. And just to give you an idea, when we built the station, because there were so many people that participated and made this happen, we actually brought all the materials by boat to shore. And between the Gitga'at First Nation, WWF Canada, and ourselves, we actually put this station together. And now we're very fortunate to do a lot of great work from that particular area, which is in very close proximity to whales and a hydrophone network, which Ben will be speaking to in a bit here. We also work very closely with a partner organization, the Pacific Orca Society, which is Orca Lab, which is where I'm actually at the moment. And it's located on Hansen Island, which is near the top end of Vancouver Island. I'm looking into Blackney and Johnson Strait. And we do a lot of great work together. And it's that type of partnership that actually grew into what we now refer to as the BC Hydrophone Network. And this is a collaboration of First Nation communities and NGOs that are interested in understanding whale habitat and ocean noise in their particular regions. And now we're able to compare this to other areas working together to better protect marine space for whales. And we'll be talking a little bit more about that throughout the webinar. So now I get to talk about whales, which of course is, I think, why most of us are here and what we're all trying to protect together. So the three species we study are fin, humpback, and orca. But for tonight, I will be focusing more on humpbacks and orca through my presentation. So I'm going to start with fin whales. So fin whales are the second largest animal on the planet. They can measure up to 70 feet long, but they're also one of the fastest cetaceans on the planet. And the reason for that, as you can see in this picture, they're extremely streamlined, which allows them to move through the water very, very quickly. We've even actually seen these large baleen whales porpoising on the surface, which is just an incredible sight. Years ago, they were once the most abundant, but for that reason, they were also heavily whaled. And unfortunately, today, they're also the whale that is most often struck by a vessel. They started to return to our coast, especially up in Gitga'at territory back in around 2006. That was the first year we actually saw a fin whale. And since then, we've been documenting the population, and it's been growing rapidly, which is wonderful. And now we've actually identified close to 100 individuals. And of those 100 individuals, a high percent of those whales keep returning year after year, which is really exciting for us. And also quite unique to have fin whales coming into a fjord system. We've actually even been able to ID a couple of whales from shore, which again is extremely unique. The thing about fin whales is they have two key adaptations for lunge feeding, which is their preferred method of feeding. And they usually lunge feed at depth, though once in a while we do see it on the surface. And as you can see in this photograph here, they have these baleen plates through this area, through their throat here, which allows them to really expand their throat and mouth. And what is also really interesting, they have what's called an inverted chameleon tongue. And you can see in this photograph that it actually will go, when they open up their jaw, it actually stretches back behind. And then when the jaw opens up, it goes all the way back here, which is just truly incredible. And this allows them to lunge feed on very small species like krill, but they also will feed on herring and other small schooling fish. And there's still a lot we need to learn about the social structure of fin whales. We do know that they do as well have quite strong social, trying to do some work to try and clarify that. They're also very dependent on sound, and they generally communicate in around the 20 or 40 hertz range, which is, of course, outside of our hearing. So in order to listen to fin whale calls, we need to actually take the recording and speed it up. But one of the better ways is also to look at a spectrogram, and I know Ben's going to be talking about that a little bit. But I do have a recording here that we have sped up so you can listen to it. It will be a little bit faint. It will be a pulse-like call, but while you're listening to it, if you look at the spectrogram, which is up above here, these are the little pulse calls that you would be listening to. So I'll play that right now. And I don't know if you could hear it, but in the background, there was almost like a little bird whistle. That was actually a humpback whale. Um, but because it was sped up, it sounds like a bird. That's not actually what a humpback would sound like. And I'll be playing some of that in just a minute here as well. So orca, we are actually really extremely fortunate along the coast of BC because we actually have 3 ecotypes in British Columbia. We have the resident, which both the north and the southern resident populations. We have offshore, which I won't be speaking too much about tonight because we don't see them very often. And so I prefer to focus on what we actually have the ability to research. And as well, bigs, or what the common name is, transient. So they've been called both. So I hope that's not going to be confusing for everybody tonight, but transients and bigs are the same whale. And as you can see in this picture, when you first take a look at them, they look very much alike, but their culture is very, very different, especially their diet, and even the way they look and the way they behave is very, very different. And a lot of that is based on the fact that they have very different feeding strategies. So I'm going to start with northern resident orca and talk a little bit about that social structure. So northern resident orca, they feed on fish, primarily salmon, and the population is actually broken up into 3 clans, and those clans are broken up into pods, and those pods are broken up into families. And each clan actually has their own language, and each pod would have their own dialect, and a matriline, they have their own dialects, but they also have particular calls that perhaps only that matriline will use. So that's why when we start talking about hydrophones and listening to whales, that's why it's such a great way to study orca, is because just by listening, a lot of the time we can tell which population is in the area. And I will be playing some of those calls for you. And just to go into that a little bit further, so one of the reasons that clans, pods, and families actually have their own language or dialect is because a family or a matriline will actually spend their entire life together. So what that means is that the sons actually do not leave their mother. The daughters as well will stay with their mother, but as the daughters start to have offspring, and then those offspring start to have offspring, you can end up with a family that may have a great-great-grandmother, a grandmother, and a mother, and all of their offspring. And at that point, they might start to break off and form their own family groups. But a lot of times they will come back together, but what they will always share is that acoustic tradition and that dialect. So again, just by listening, we know what families or pods or clans are in the area. So I'd just like to play a couple of examples of this for you. And even though it might be the first time you've listened to orca, I think even the first time you'll note that they are quite different acoustically. And I'll play 3 different examples for you. And this next recording was recorded from Orca Lab. And so Paul and Helena, I know you're going to recognize this one right away because it's one of our favorites. It's actually a combination of two different clans, A clan and G clan. So the G clan calls you'll hear, they're like little pings, ping, ping, ping. And then the A clans are more of a mellow woo you'll hear in the background. So these two clans were traveling together in Johnson Strait, and this is recorded at about 2 a.m. in the morning. And one more, just as a comparison. Oh, sorry. Try that again. So they are acoustically very different from one another. There is no doubt. And I hope that even though that might have been the first time that you were able to hear that. And I'm going to go on to the next slide now and talk about Southern residents. So Southern residents, because their population is so small, and as we all know, their population is in trouble. So it is really something to keep in mind. So with the Southern residents, there is actually only one clan, and that clan is broken up into 3 pods. But these pods do sound a little bit different from one another. So I would like to play some of those calls for you as well. Before I go into that though, I just want to mention, so the Southern residents and the Northern residents, though they're acoustically different, their culture is very much the same and their diet is the same. They both will be feeding on primarily salmon. And then this is K-pod. And L-pod. So the calls to me are very similar, and that's probably because they are of the same clan, but there are slight differences. And I just wanted to make a note that even though Northern and Southern residents culturally are very similar, though acoustically quite different, they do have different ranges. So the Northern residents use the North Coast. So if you go from about Campbell River up towards Hartley Bay and up towards Alaska, that's where you would generally see the Northern residents from Campbell River south down towards Victoria, Salish Sea, and towards Washington. But there are little areas of overlap. So even though it's not in red, this little area here, it tends to be an overlap, especially with G clan whales coming from the Northern residents. And of course, every once in a while, we do have Southern residents up near Orca Lab, which is up in this area, which is always really exciting for us when they show up in this particular region. Even though they have overlap, though, they do not associate with one another. There's no conflict between them, but it's been pretty rare to see sightings of them interacting with one another. So the bigs are the transient orca, the wolves of the sea. So these are the marine mammal hunters. These bigs are the whales that will go after sometimes other whales. They will also go after seals, sea lions, Dall's porpoises, dolphins. They really do act like a pack of wolves when they're hunting. It's quite incredible to watch them. Lots of times we've seen them, they'll be traveling down the shore where half the family will be close to shore, and the other half is about 100 or 200 meters off, and they'll be traveling along, and then all of a sudden, let's say a group of Dall's porpoises will get in the middle, and then the hunt begins. Um, Biggs, orca don't always stay in these really strong family groups, so there are definitely strong family bonds, but they are known to split up and then come back together frequently. As well, because they're in hunting mode most of the time, they tend to travel in silence. So because they're traveling in silence, that opportunity for that acoustic dialect to be passed on from generation to generation, it's still there, but it's weaker in regards to in comparison to the residents. So residents, they have all these different call types, whereas Biggs or transient orca, they have call types, but they're all very much the same. So when we're listening Biggs, when they're hunting or vocalizing, we can't always tell which family it is. Whereas with residents, we can actually tell which family or at least clan or pod is in that particular area. So what I'd like to do is just play a recording of that. I also just wanted to put this picture in here. So this picture was taken at a great distance, but I don't know if you can see, but these are two orca and they are actually swimming around the sea lion rock. And what they did is they kept swimming around and around the rock, and you can see the expression on the face of these sea lions. They're not very happy. But what that technique did in this particular instance anyway, is it actually caused a couple of the sea lions to panic and actually come off the rock. And that's when the Biggs went in and made the kill. And it was interesting is when this kill occurred at that moment, we only had 5 whales in the area. And after a kill is made, that's when Biggs will start to really vocalize. And while they were vocalizing, all of a sudden we had another family arrive and then another family arrive, and we ended up with almost 20 whales that shared in this foraging moment. And you could tell they were really working together. And it is known that, even though we think of transients as killer whales, underwater, what you would see is they actually share the prey. And I think that that really speaks highly to them. I think that's pretty incredible. Same with, I will say, residents, they will also share a salmon. That's also been documented underwater. So pretty incredible that they think about the family or other whales at the same time while they're foraging. And I just want to play a call for you here. And what I think so interesting about that call is that it's just such a soft, gentle call, which is not necessarily what you would expect from a whale that's perhaps just killed a sea lion. But yeah. So humpback whales. So I think as many of us here know, humpbacks have really come back to the coast of BC. They are doing very well, and it's a really good story to share with people. Um, and they are a migratory whale, so that means that they migrate from Hawaii. So they will travel from Hawaii. They're probably just starting to migrate now back towards our coast. And the reason that they're coming to our coast is because this is their feeding grounds. They're coming here to feed. So our area is very, very important for them when they arrive. And then they'll leave again near the end of winter, or the beginning of winter, I should say, around November, December, and they'll travel back to Hawaii, to the warmer waters, where they will calf and breed. And I just like to emphasize, when they go to Hawaii, they generally do not feed. So a mother, for example, who's just given birth to her calf is now nursing her calf. When she goes to leave Hawaii, she is going to have to travel 3,000 miles to get back to our coast in order to feed. And what's also really interesting is that humpback whales do not stay in these family groups. So that mother and calf bond, though it's extremely strong, it's only going to last 1 year. So what that means is that mom has 1 year to teach that calf everything that it needs to learn in order to survive. But what humpback whales do have are very strong social bonds. Social bonds with each other. And what we now recognize that some of these relationships have actually gone on for over up to 20 years. So because we've been documenting this population and taking a picture of their tail flukes to identify each member, not only in our particular region, but this is now happening up and down the entire coast of British Columbia, we now can look at whales that are being seen together over and over. And we have some whales that are known to associate with each other now, like I said, for almost 20 years, year after year. But what we've also really noticed is some of the stronger bonds we see is when it comes to a feeding technique known as bubble net feeding. So back in 2004, we had a group of humpbacks we referred to as the usual suspects. And it was 14 to 18 individuals. They were always seen together. They were always bubble netting together, and they were always coming back year after year. But over time, as the population of humpbacks grew, as did the number of whales that were bubble net feeding. So this core group of humpbacks started to bubble off and join and teach other whales to bubble net feed. And so now in the area, we've gone from a group of 18 humpback whales. We now know that we've had over 200 humpback whales bubble net feed in the area. And this technique, though mainly seen only up in Git-Gat territory, in around Prince Rupert, and now going down into the Central Coast uh, in around Klemtu and Bella Bella. So that type of feeding strategy is spreading its way down the coast. Not a lot is seen yet in the Salish Sea or in the Johnstone Strait region, but I wouldn't be surprised if over time that transmission of this feeding strategy spreads along the entire coast, because it's just an incredible way to get food. And Grace is going to talk a little bit more about that. But what I'd like to share with you is the bubble net feeding call, because they always use this call when they're bubble netting. So when we hear this call over the hydrophone, we actually can put a behavior to a call type humpback whales. And that call has changed so much over the last 20 years that the first time I played the beginning to Ben, we were debating whether it was a bubble net feeding call. That's how much it's changed over time, but that's a whole other presentation and topic. All right. So this is my last slide, and probably to me, one of my more, for me, it's an important slide because it really is listening to humpback whales and the humpback whale song that as a child really inspired me and is why I'm here today anyway. But the humpback whale song is incredibly complex, and it's made up of phrases that are repeated over and over, and that will create a theme. And these phrases and themes can change as whales from different parts of the world can socialize, and they're literally creating an acoustic network. And, you know, a lot of times we ask, well, what is the purpose of this song? And at the moment, you know, we really don't truly understand the entire purpose. You know, perhaps there's more than one purpose to this humpback whale song. What we know is that it's mainly males. It is males that are singing this song. Though females are also very vocal, but it is only the males that have been documented to sing the song. And what we do know is that this song has spread and evolved throughout all oceans, all over the world, and it's developing this acoustic community that connects whales worldwide and is potentially forming lifelong relationships. And the song itself is it's always changing, and it's always evolving, and it's being passed on to all members of the community. And all males are actually incorporating these changes into their own song as populations come into contact with each other. And so this song is literally changing and evolving from year to year. So what I wanted to do was just play you an example of a song from a couple of years ago, and then a song a few years later. And they're so different. It's just incredible. right. And this was just from a few years ago. Very, very different. And with that, I better stop because I've already gone over time because I got a little carried away. So with that, I just want to end my particular part of my presentation just to say that, whales are definitely a culture. They have a lot of culture. Every whale species has their own culture, and it's all about acoustic traditions, and that they're just a really important species. And I think it's incredible that we have the opportunity to share our coast with whales and to listen to whales. And with that, I'm going to pass it on to Tom.
Thanks, Janie. Share screen. Okay, hopefully everybody can see the screen now. So my portion of this little workshop is going to be on underwater sound and noise, which happens to be what I've been spending the last 30 or 40 years doing. So we're going to cover a little bit about why sound's important and why or how we measure sound and what can sound tell us about what we're looking at in the ocean. So to start with the importance of sound, there's lots of different types of energy that can be used to sense your surroundings in the ocean, but none are anywhere near as good as sound. Sound is by far the most important form of energy for looking at the ocean, exploring the ocean and your surroundings within it. For example, Janie was talking about fin whales there. Fin whales and blue whales can make calls that can travel over entire ocean basins. And as humans, we can do the same thing. We've run experiments where we have sounds from Hawaii here, and we can hear those sounds all the way across the Northeast Pacific on the coast of Vancouver Island here and up in Alaska. So sound travels really efficiently in water and a long way. And it's really useful for exploring the environment. Just to show a little bit about efficiency, sound travels about 4.5 times faster in water than it does in air. And as a result of that, marine life has evolved to take advantage of sound. And for most marine life, it is their primary sense. Like for us, it's vision, but for marine life, it's acoustics. So it's an acoustic environment that they live in. And there's a whole bunch of uses for that sound that they've adapted to over time, like communicating with each other, for navigating their surroundings, for attracting mates, and all kinds of other uses there. And probably the most important one would be for listening to sounds of predators coming by as a warning sign. And I wanted to note that it's not just marine mammals that make sounds in the water. There's this, like the sea lions and the dolphins and the whales, but crustaceans make sounds, and fish make sound. There's well over 1,000 fish have been documented to use sound in the water. And this particular fish here is the plainfin midshipman. It's very abundant in the BC waters here. And this is what one of those fish sounds like when it's vibrating its swim bladder to make sound. So if you have thousands of these fish in a bay, you can actually hear them above the water. They're so loud. So it's not just the marine mammals that are making sounds. There's also weather things and other animals too. And in addition to marine fauna or marine animals, humans also use sound in the sea. Now, I'm not going to go through this whole list for you because it would take me forever. But there's a lot of commercial or industrial uses for sound, and in academia and research, there's a lot of research uses for sound. So as humans, we on purpose pump a huge amount of acoustic energy into the water. And in addition to all that intentional acoustic energy that we put into the water, we have a whole bunch of unintentional sound that humans put into the water. So some of this comes from recreational boating, some comes from construction, for example, pile driving or dredging to clear shipping lanes, or shipping noise themselves. Now I'm going to go into shipping noise in a bit here, but I wanted to show you an example of pile driving. Now, pile driving, steel piles like this, is one of the more particularly deadly sources of sound in the ocean. So I'm going to play you a short clip of them driving a steel piling into the water here. Oops. Scroll this over to where it actually starts driving the piling in. So that's the hammer driving the piling down. And underwater, it's even worse because a shock wave forms and it can actually kill animals within 10 meters. The sound from this can kill animals within 10 meters of that pile drive. Okay, so let's move on to shipping noise. So here's a clip of a ship going by, if I can get my mouse to move. So this is a container ship. So that sound pervades, and it's loud enough to carry over about 65 kilometers or so through the water. So it really propagates a long way. Now, this little picture that I'm showing here is shipping density. So it's how many ships are moving through an area over the course of a year. So every pixel that you're seeing here, the color shows you how many vessels are moving through that pixel each year. And so the dark red regions are in the thousands of vessels per year moving through this area. And what you can take away from this is, in all of the dark red areas along the BC coast here, in those dark red areas, there's never a time when you're not listening to ships. It's always ship noise constantly. So if you're an acoustic animal making a living in these waters on our BC coasts, if you're in these dark red areas, you're going to have a hard time. So that's the takeaway from this. So where does all that noise come from off of these boats? Well, if you think of that container ship that I just played there, those are big ships. They could be 150 meters or 350 meters long. They have a hull on them. It's this thin layer of metal over the whole thing. It's stretched like a drum skin over a drum. Or if you look at these instruments on the bottom of the slide here, these are called soundboards. And if you vibrate one of these small little strings here, it doesn't make a whole lot of noise. But if you connect that to a soundboard, like on this banjo or guitar or piano, or even the sound cone on a speaker, it couples that energy really effectively into the room. Same thing happens with a boat with the hull. So if you mount something onto the hull of the boat or onto the deck that's welded to the hull, like a generator, for example, to produce electrical power for the ship, or the ship's engine, or the gearboxes, or the shaft, anything that's connected to the hull is going to radiate that energy really efficiently into the water and make this vessel really loud. That's not the worst of it, though. The worst is from the props. And so the issue with the props is that there's something called cavitation, and that's all these little bubbles. So cavitation is just like boiling water. When the propeller starts spinning really fast and this blade is moving through the water, the water can't rush around in behind the blade fast enough to get in behind there. And that really drops the pressure, creates a partial vacuum. That water flashes into water vapor. So it expands really rapidly, makes a big bang, And then when it comes off of the propeller into the high pressure water behind it, it collapses and implodes, and it's just like a miniature explosion, except in reverse. These explosions and implosions are so violent that it can actually erode stainless steel, like you can see on the bottom of this propeller here. So very, very violent. And there's millions of these bubbles that come off. So this is extremely loud. And so that's where most of the noise comes from on a vessel. So all these whales and animals making calls and the ships making noise in the water, how do we measure that? Well, we use something called a hydrophone. And so a hydrophone is just an underwater microphone. It's just that seawater is really corrosive, and electrical instrumentation doesn't like it very much, so they're much more expensive to build than a regular microphone. And there's analog ones that just produce a voltage, and then there's really high-tech ones that we use in the research community that are really well tuned, and the electronics are tuned to the acoustic front end, and they output a wave file just like on your sound files on your phone, except they're calibrated, and so we know exactly what the acoustic pressures are and acoustic energy is that's coming out of these devices. Now, these smart digital hydrophones, we have two really good manufacturers in Canada that produce these things: Ocean Sonics with the IC Listen that you see here, and Jasco with the AMAR, which you see here. And we use both of these on the coast of British Columbia to collect our sounds. But it's not just about the hydrophone. So forgive my crude graphics, but if we start at the hydrophone over here, we put in a little protection cage, we put a little shroud on top of it to protect it from sea urchins chewing on it and barnacles growing on it and debris hitting it. That's mounted on a small mooring on the seafloor, generally about 20 meters below the surface. And then we run a nice, really expensive underwater cable up to the shore, runs into this electronics box here, where we collect all the data from the hydrophone. And we have solar powers and batteries to power all this stuff. And most of our sites have a radio so that we can radio all that data back in real time to the lab where the researchers are, so that they can listen to all this stuff and view the spectrograms in real time. Now, in some sites that don't have a lab nearby, we'll put in a little hard drive in there to record on site. It takes 3 people about a day and a half to install one of these sites, so it's not a small endeavor, and they require quite a bit of maintenance too. Okay, so we've got all this sound gathered and sent back to the lab. What do we do with it? Well, the first thing we do is we hand it over to Ben and we say, hey, process all this data. And Ben will talk to you a little bit about the processing of this in a bit. But I want to tell you what kind of information you can get out of this sound. And you can see I've listed a few things, like you can look for the sound of rain and wind and waves and earthquakes, for all the ambient noise. You can look at different species. If you hear a call from a species, you know they're present there. There's certain calls, as Janie was talking about, you can tell whether they're foraging or whether they're socializing or transiting through an area. We can look at the human noises that are generated and make assessments on how that's going to impact the species that are present in that area. And then we can actually get a whole bunch of information about the boats and ships themselves. So here's an example. So this is a spectrogram, and there's lots of different ways of looking at spectrograms, but basically it's time along the bottom axis, and it's the frequency of the sound or the pitch of the sound on the vertical axis. So high pitched sounds up at the top and low rumbly sounds at the bottom. And in this case, we can see this wide band here, and that's rain. And so we can see the rain building up, and then we've got a rainstorm for a while, and then the rain dies down, and then there's no more rain. And you can actually tell how much precipitation has been dropped from this as well. So, and you can do that for all kinds of other sounds, analyzing it this way. You can take it to the extreme in the case of boats. So this is an experiment that we ran at one of the partner organizations at Saturna Island, Simres. And this particular spectrogram was generated by Ocean Networks Canada a couple years ago. Ben's spectrograms look somewhat similar to this. And they're all the spectrograms are kind of similar. They just have a little bit different coloring and scales. But what we can see here is it's kind of quiet. The vessel's coming in. We have a bunch of lines from the vessel and then a whole bunch of cavitation noise from the propeller. And so yeah, there's a boat just went by the hydrophone, and then the boat goes away from the hydrophone and gets quiet again. So what can we learn from this? Well, we can see, wow, this cavitation is going way up in frequency. It actually goes up above 60 kilohertz. That tells us that that propeller is cavitating dramatically. So it's a fast turning propeller making a huge amount of noise. And doesn't matter what animal you are in this area, whichever band of the frequency you're using to make a living in this area, this boat's affecting you. You're going to have to shout over it. So what else can we learn? There's a whole bunch of flat lines here. So that tells me that this vessel is running on a straight line. It's not making any course corrections. It's not making any speed changes. So it's just running in a straight line. There's a little black spot below here that goes up to about 120 hertz. That tells me that the propeller is right at the surface. So this vessel is up on plane and boogieing along on the water. We can look at these lines and we can estimate the Doppler shift on them, and we can say that, yep, this boat was going past the hydrophone at 30 knots, and it was 270 meters away from the boat, or from the hydrophone. And then we can look at some of the spacing on some of these lines, and like over here, and we can say, yeah, that propeller, the shaft rate for that propeller was 2,350 RPM. The engine will be turning a lot faster than that, obviously. So then in this experiment, then we handed it over to another researcher and said, okay, well, how well did we perform on the acoustics? And this is a picture of that particular boat. The hydrophone is, if I can get my mouse down there, the hydrophone was sitting right down about here. So we've got our distance about right. We've got a boat that's traveling straight. It's a high-speed boat. It's up on plane. So we did pretty well. Now, this hydrophone is in a marine protected area, an interim sanctuary zone. So we can actually estimate whether these boats are infringing on the marine protected areas just by using the acoustics. So we can tell a huge amount from the acoustics. Okay, last point that I'm going to make is on masking. Now, masking is when it's really noisy and you can't hear the calls that are being made. So if you picture yourself in a noisy bar with loud music playing, and you're trying to have a conversation across the table to your friend on the other side, and you yell louder and louder, and everybody else starts yelling louder, it keeps getting noisier and noisier. Pretty soon, it's pretty much impossible to have a conversation. Same thing applies in the ocean. So if we have a large vessel going by, like in this case, a container ship going past the hydrophone. Now, in this example, the container ship is 2 kilometers away, and there's a whale calling, and it's much closer. It's about 1 kilometer away. So I'm going to play this little clip and see if you can hear the whale behind all of the ship noise. You can hear it, but you have to know what you're listening for. So this was a call by the endangered southern resident killer whales. In fact, it was J-pod. So if we filter out the boat noise here, so that you can better hear the whale call, this is what that whale call sounded like. Now that was a yeehaw call, and if you go to Scott Veers, who's on the call right now, I learned from his site that yeehaw call is made by J-pod, so we know exactly which pod it is. Okay, so I'm going to end it there, but I will say before I hand it over to Ben that I love talking about this stuff. So if there's any questions that you don't have answered in the question and answer period at the end of this, give me a call or send me an email. I would love to chat with you about it. Okay, Ben, over to you, I think. Let me stop sharing.
Awesome, Tom. Thanks a lot. Let me share my screen. Okay. Actually, I probably have to just give me a second here. Go to this. Okay. Everybody seeing the right thing? Awesome. So the story that I'm going to tell today is about how machines are listening for whales. I'm a software engineer, so naturally my talk is a little bit more tailored towards the technical side of analyzing whale sound in the water. And you excuse my voice, I just choked on my tea 2 seconds before the talk, so you have to deal with that. Sorry for that. So the talk is about how machines are used to listen to whales, and with this, how we create a network of knowledge for the community stewards and scientists along the coast of BC. But before I want to talk about machines, I want to talk about whales. And more specifically, actually, I'd like you to imagine for a second that you are a whale. And being a whale, you recognize how different you are from a human. I assume that's obvious, but the specific thing that I want to highlight is look at how humans find their food. They use their eyes to, for example, find berries or mushrooms, and they use their eyes to assess whether the berries are edible or not. And if you want to protect your territory, you may place a companion that you trust on a lookout, and tell him to spot for intruders. If you are teaching your children, as a human, you may tell them to watch out. And if you want to find a mate for you know what, then you may be wearing jewelry, making your hair, dressing nicely, or going to the gym. For what reason? Because you want to be seen. So now you're a whale. And if you're in BC waters, you may not even see your own fluke. That's how murky it is. And that's how unusable your eyesight actually is. Whales are not blind. They can see, but they use sound for all these things. So when they want to find food, they either echolocate or they use sound to corral the herring that they want to eat. And if you're a whale and you want to protect your territory, then you listen for predators and potential enemies. And if you want to find a mate, of course, what do? You sing. Because everything that's critical to whales is done through sound. And this is really the point that I want to bring home, that sound to whales is the critical component for their livelihood. And this is why I come back to the plot that Janie already showed, that hopefully motivates why it is so important to have hydrophones in the water and to listen to whales and to understand their acoustic habitat. And this is where the BC coast-wide hydrophone network comes into place. Each of these triangles is not just a single hydrophone, but it's a whole monitoring site with sometimes 4 or 5 stations that listens to whales and monitor the sound in the ocean to streamline the acoustic data collection and also the data analysis for coastal communities along the entire western coast of Canada. And I really, Tom, like the description you just did about the propeller and the noise of the boat, because what it highlights is, Tom, you spent about 10 minutes describing the single spectrogram we saw. But these hydrophones produce hundreds of terabytes of data per year, hours and hours and hours. So no Tom and no Janie can ever sit down and listen to these things. And this is the point where kind of my job begins and where now I bring the machines into play. But before I go with the machines, I want to repeat a very similar call that Janie played before, and maybe you recognize it now. So those are humpback whales carrying out a basic life function, which is finding or corralling the herring they want to eat. And for us humans, we listen to that sound. And for machines, it is very difficult to listen to something. So what we have to do for machines to be able to work with sound, we have to translate the sound into a sound image. And in order to do so, we use something that's called a spectrogram. And you've seen it in some of the talks, but I really want to show you what it means, what we need to do to make the machines being able to work with sound. So for a second, I will stop sharing and open another tool. That is doing exactly this. So this little software is translating my voice at the moment into an image, into a spectrogram that a machine can analyze. And because I've heard Tom talking about rumbling ships, Tom, I may take you on the spot. Maybe you unmute yourself and give us a good rumbling noise here.
That does put me on the spot, Ben. It's about the best I can do.
So this here is Tom's rumbling noise. And maybe Grace, you're next. Maybe you want to give us a high-pitched tone.
Oh boy. Woo!
There you go. Beautiful. So you can see this is exactly what the computer needs to do. It translates our voices or the voices of the ocean into a picture. And we all know how great the ocean is to, or computers are to, how great computers are in interpreting pictures. All you need to do is you need to hold up your cell phone in front of your face and it will open up, and because it did automatic face recognition. Nothing else than a machine interpreting a picture. So that's the first thing we do if we study whale sound, which is translating the bubble net feeding call that I just played into a spectrogram that looks like this. And then the first thing we do is we let the computer count these things or detect them. Where and when are these happening? And obviously in the single sequence, we already have 20 of them, but over the year, we collect thousands or tens of thousands. And the next step we do, very similar to a face recognition on a cell phone, is we let the machine decide what it actually is. And in this case, it says it's a humpback whale doing bubble net feeding. The reason why we can do it is because every sound in the ocean has their own acoustic fingerprint, whether it's an orca or a humpback or a vessel, or even our system that adds noise to the ocean. Everything has its own signature, and the machines, if it's properly trained, can tell us what it is. So from the classified and detected calls, we can start generating knowledge. And that knowledge can be as simple as saying, during which month of the year did we hear these humpback whales? And the plot here shows, well, they've been mostly present between May and September, and the activity peaked in August. And oh, it was also more often present during daytime than during nighttime. If you have the right setup of hydrophones, and in this case, you don't even see all of them. This is in GitGet territory. It's called the SWAG project, and there's 4 hydrophones located in this box here. If you put them together correctly, we can use machines and compute the spatial positions of where these whales do their bubble net feeding. So each little dot on this map is a bubble net feed of a group of humpback whales, and it tells us a lot of where they're doing it and how they're using the habitat, and maybe where they're most vulnerable. Next, if it's not just a single call that we're localizing, but if we're localizing over time, you get something like you can see in this video. So a whale may be moving around and being vocal for a longer period of time, and what we obtain is something that Janie would call whale trails. So we track these individual localizations and combine them, and we get the spaghetti plots, which tell us how the whale moved. The red lines were during the day, the blue lines were during the night, and a lot of characteristics about their swimming speed and other things that we may be interested in. And I will play, because this is not a humpback whale here, this is also a fin whale. I will start playing the same sequence that Janie played before, where the fin whale is sped up and you should hear the low whooping sound. And now for everyone who got frustrated in the first clip, who said, I've never heard a fin whale before in my life, and then Janie played one and you could still not hear it. I recognize it was very faint. Now it's a second effort. Now it's sped up 30 times. And I hope now really everyone can hear these fin whales. So they would do this sometimes for hours at a time. And you can imagine if the machines keep localizing these calls and the whales keep swimming, then you obtain these nice whale trails that tell us where they are and how they're moving around. And the second half, I want to focus on the fact that whales really depend on acoustics for a living, which is great for us because we can study them. We can study their sound, which they're making all the time, but it also puts them at risk, or it at least is a concern if they start sharing their habitat with vessels, which, as we heard before from Tom and Janie, produce noise and therefore potentially creates an imbalance in their livelihood. So the three layers that exist as a risk factor between vessels and whales in the area starts with a ship strike. That's sort of the most direct impact you can imagine. It's a physical collision between a whale and a ship, and usually it's the whale who's taking, the short straw in that equation. Acoustically, it is also very interesting to consider that their listening space is reduced. And with that, I mean that if you start to introduce noise in the ocean, it doesn't kill you, but it makes your ability to listen maybe from a 10-kilometer range reduced to 5 kilometers. So you're not seeing, hearing your prey anymore. You're not hearing your predators anymore. And the way that I like to describe it as a sort of acoustic fog that rolls in if a vessel enters the area. So where we are restricted, if we are fishing and we're entering fog, we're not able to navigate as well anymore. In the same is true for whales. If they experience this acoustic fog, their ability to live is restricted. And the third layer is stress, which is not really well understood in the scientific community, but it's proven that it exists and it is a reason for concern and something that we definitely want to have our eyes and ears on because it is caused by vessels also. So how do we use machines to study this? The plots here is the output that we get if we combine acoustic recordings into 1-minute little bins and ask the machine, what is the noise level for each of these minutes? And each of the plots shows a calendar day. And you may recognize that it's kind of a nice line. The dark line is actually what we think the soundscape sounds like without vessels. And then you see these little spikes in there. And each of these little spikes is probably a vessel. The small ones are from smaller recreational fishing boats, and the large ones is here, in this case, from a cruise ship or a carrier or a tugboat. So the soundscape is fogged by these vessels. And what we do eventually with our machine analysis is we're trying to understand how much it is fogged and how often. So for example, we can use the previous example and create a daily average for a whole calendar year. And now we have a calendar where for each day we get an information about whether the day was quiet. So it's a clear sight, a clear acoustic sight for the whales, or whether the day was noisy, which would be the red days, which is the equivalent of a thick acoustic fog they're experiencing. So I have a couple of little snippets here again. This would be a very quiet day. And if you didn't hear anything, this is exactly what it's supposed to show. This one here is a day that is sort of yellowish in between green and red, and this may be a soundscape sounding like this. And then, of course, you have your dark red days, which means it was really noisy, and the whales experience really thick acoustic fog. And sometimes it's weather causing it, but sometimes, of course, it's also vessels. And then the soundscape may sound like this. So some of how many of these days are green and red is determined by the weather and the environment, but some of it is depending on us and our decision making, how we use a certain marine area. And that's what I want to highlight with this plot here. And then the final slide to conclude is a project that we started with our partners across the border in Washington State. It's a collaborative project between the SWAG project, BeamReach, BC Wales, and my company, Soundspace Analytics, which aims to get the basic and most easy to interpret acoustic data from the ocean to users on their cell phones or on their PCs at home, because we believe that it is really a community effort that it takes to create that balanced ocean and to create the awareness. So we're working hard in the last year to create that fully automated data flow from the hydrophone that Tom described, that is put in the ocean and stored on land, through the machine processing on site or anywhere else with the algorithms that I compute, and then putting these information into the internet and putting them into graphics that are really easy to interpret and to understand, so that everybody can start to see how the ocean is acoustically being used by whales and also by vessels. And I think with this is a project that is close to being wrapped up, and I think it will go online before the end of May. And if any of you are interested, I really like to encourage you to reach out to either Grace or Janie and just get in touch with them to see if you can gain access to these pieces of information. And with this, I will hand it over to Grace.
Helps if I'm unmuted. Thanks, Ben, for passing that back off, and thanks to everyone for these talks. It's always so great to be able to listen to this great group of people and learn something new every time. One thing I'd like to mention before diving into this again is just, if you have questions, please put those in the chat. We are monitoring that, and we'll be opening it up for a question and answer period after this talk. So with that, I'll be sharing a little bit about specific whale foraging tactics and some of the additional threats that whales are facing today. So to begin with, I think it's really important to recognize that whales are top predators. They've evolved alongside their prey, and this has led to some really incredibly diverse ways of feeding all around the world. A few examples here are intentional stranding from a few orcas in Argentina, skim feeding by whales like the right whale in the top right here, bottom feeding or mud sucking from gray whales, and trap feeding, which has been seen in multiple species all over the world. And part of the reason for this great diversity, if we bring it back to the basics, can be explained by morphology. So if we think broadly, there are two main types of whales. There are whales with teeth, and there are whales with baleen. Baleen is acting like a sieve or a really specialized filtration system that traps food but lets water escape. And the way whales with teeth can feed is going to be different than the way that whales with baleen can feed. And Janie touched on this a little bit earlier with rorqual whales, but within baleen whales, there's this really special category of whales that have throat grooves. And when they open their mouths, water rushes in and it expands that throat, and it lets them take in massive amounts of water that's prey infused, and it has supported them in becoming some of the biggest species that Earth has ever experienced. But there is a cost with this type of feeding. When they open their mouths, they're experiencing a huge amount of drag, and they can actually come to a dead stop in the water every time they lunge to feed. So this increased drag means that these whales need to be really strategic in being able to get the most bang for their buck when they're feeding. And so with that background in mind, let's focus in a little bit more on humpback whales. So Janie touched on this as well, but just to keep in mind, humpback whales are migratory. They're feeding at high latitudes, cold waters, and they're breeding in the tropics. And so for the whales in BC, this means that twice a year, they're needing to go back and forth between primarily Hawaii or Mexico. And when they get to BC in the summer, there is a need to feed. So within BC alone, humpback whales have been seen using many different feeding strategies. These have included things like lunge feeding, skim feeding, trap feeding, flick feeding, and of course, bubble net feeding. And it highlights for us that these whales are incredibly intelligent, and they're making use of different feeding strategies depending on the type of prey that's available, but also the knowledge that they're learning from each other. And just to highlight again that whales that are rorqual are experiencing drag, just take a look at this video where this whale comes to a dead stop as she's opening her mouth to feed. So within our research area, you've heard a little bit already about bubble net feeding. This is an incredibly unique and specialized feeding strategy that is used by humpback whales only in certain parts of the world and only by certain individuals within those populations. So Git-Get territory might have actually been one of the first places along the BC coast that bubble net feeding returned after commercial whaling. And from our photo identification work, we know that the same 9 whales have been feeding together in this region every year for more than 16 years. We've also watched this behavior grow in this population, as Janie mentioned, from 18 individuals in 2004 to now more than 200 whales know how to feed this way. And what is of great interest is that we do believe that this behavior is being passed on socially, and we're actually in the process of writing this up for publication as well. And for now, of course, as Janie mentioned, this is pretty unique to the North and Central Coast. So if we dive into the actual mechanics of it all, during bubble net feeding events, humpback whales are trapping schools of fish through a combination of bubble blowing and really specialized vocalizations. And in a typical bubble net feeding scenario, we're seeing groups of 2 to sometimes more than 15 whales descending together to depths of about 20 meters and organizing themselves into 2 main roles. These are callers and bubble blowers. And it's currently believed that the callers are going below a school of fish, vocalizing that bubble net feeding call. And at the same time, bubble blowers are swimming upwards in a tightening spiral, creating that actual bubble net that's going to trap the fish. And some folks have actually looked into how herring responds to being trapped, and the curtain of bubbles alone is enough to try to stop them from wanting to swim outside of the net. But it's also been found that that feeding call actually makes a wall of sound that's the loudest within the bubbles and further prevents herring from trying to escape. So as that net rises, the fish are trapped, and all together, cooperatively, these whales lunge through the center and get to feed. So BC Whales and NCCS has been studying bubble net feeding for almost 20 years in Git-Get territory. And this has been done historically through photo identification, which is telling us which whales are participating in bubble net feeding, but also through acoustics and looking at the actual feeding call, which, just to remind you, sounds a little bit like this. All right, but of course, there are still things that we don't know about bubble net feeding. We know that certain roles exist in these groups, but there's still a pretty big knowledge gap around who's doing what and does it change in terms of these roles. We also don't know how surface behavior is relating to that role partitioning that might be happening with these feeding groups. And so adding drones is really helping us to try to piece this all together. So adding this top-down perspective, we're beginning to be able to look into pre-dive formations and pairing that with dive order. So looking into where a whale is positioned in these formations at the surface compared to, are they diving first, second, third, and so on, and looking into, is there a pattern to that? We're also looking into pairing all of that information with where they're positioned during a surface lunge, which is what you're seeing in front of the Finn Island Station here. So looking into now, again, where they are before they dive, what order are they diving in? And does that help us predict where they might actually surface to feed within the group? And if we do find a relationship there, the next step could be to pair what we're hearing acoustically and see if we can figure out if what we're seeing at the surface is letting us know what's going on at depth. So transitioning here into a few other things that we're doing with drones. On top of using them to investigate behavior, we're also looking into conservation threats in a new way. And before going on, I just want to quickly mention that when we fly drones, we're using a specialized research permit. And in Canada, without that permit, it's illegal to fly drones over marine mammals. All right, so on top of ocean noise, which we've mentioned pretty extensively tonight as a huge issue, whales are also facing threats like entanglement, pollution, climate change. And I'd just like to take a few moments to highlight how we're using drones to address these top two. So along the North Coast, we are frequently seeing whales in resting behavior states. This is happening both as a sleeping state where they're stationary at the surface and in a resting travel state, which is what you're seeing here. And when whales are resting, they are not necessarily sinking out of the way of a risk of a vessel strike. They're often traveling at really slow speeds, like you see here. They breathe infrequently, and they're nearly impossible to detect from a vessel. So something that is really important to keep in mind is that we also don't know how whales might or might not respond to approaching vessel traffic. Another issue is entanglement, and we are frequently reminded how easy it could be for a whale to become entangled, especially humpback whales, because they are very curious. They are routinely seeking out and interacting with their environment. And on the North Coast, what you're seeing here is kelp rolling. And so the risk of becoming entangled is now not only dependent on just the chance of running into synthetic ropes or netting in the water, but now also if these whales mistake a patch of kelp for synthetic material, that risk could be heightened. And so one way that we're investigating these threats is through scar analysis. We are looking at the scars on the bodies of humpback and fin whales using drones and cameras together to try to get a better sense for how often the whales in our research area are encountering and surviving ship strikes and entanglement. And this is giving us a better idea of how pervasive these threats are, and it's allowing us to compare any changes to the health of individuals from year to year. We're also using drones to conduct focal follows as part of the SWAG project. And this is aiming to address directly and hopefully mitigate some impacts of shipping. So from focal follows, we're able to map and compare the proportion of time that whales are visible above the surface versus the amount of time that they're below the surface, but still vulnerable to a ship strike and visible from the drone. So this example here is of a resting travel humpback whale. And from the amount of time that this whale might have been vulnerable to a ship strike, it was only actually visible for 13% of that time. So this just highlights for us once again that though a whale might not be visible, it still could be present and it could be at a great risk. And one reason that we're really concerned about this is in the next few years, there is supposed to be the onset of the marine shipping of liquefied natural gas, or LNG, in our research area. And this map is showing you species and locations of whales that we documented just this past year during our marine surveys. And what you can see is that whales are often relying on habitat that coincides directly with this proposed route. So the increased risk of ship strike is going to change dramatically in the next few years. And with that, we're hoping to, with education and with chats with industry personnel, to prevent stories like this one of Moon. So this past September, a humpback whale named Moon that we have known for close to a decade swam past our research station on Finn Island in Git-Gat territory with a really severe injury to her spine. And this is very likely the result of being hit by a vessel. So because Moon has been a seasonal resident to these waters, we know that this severe bend in her spine is an injury and it's not a birth deformity. We also know that she's a mother, and the last time we saw her without injury in 2020, she actually had a calf with her at that time. So this injury left her completely paralyzed from her dorsal fin all the way down to her tail, and it made it impossible for her to be able to swim naturally. Instead, what happened was she had to flap herself, swimming with her pectoral flippers only, very slowly, And somehow, even with such a decrease in mobility, her culture and her strong instincts still drove her to migrate all the way to Hawaii. And that's what you're seeing in this photo here. So that journey took way more energy than she had to spare and that her body could handle without the ability to swim with her tail. And that suffering that she experienced was really clear to us the moment we saw this photo, where she had become extremely emaciated and also infested with whale lice. So Moon is really unlikely to make it back to Git-Gat territory this coming season, but we hope that her story is something that will remain in the forefronts of our minds every time we're on the water and considering the risk of vessel strikes. So just to wrap up here, I just want to mention that if you ever see a whale that you think might have been hit by a ship, that might be entangled or is otherwise in distress, the number one most important thing to do is to report it. So DFO has an incident reporting line, which is on the screen now. Please feel free to take a photo of this if you like. You can reach them by phone, email, and VHF radio on channel 16. We're also in the process of developing an app that will allow anyone in remote locations to be able to make a report whether or not they have cell service or Wi-Fi. So in the moment, you can collect all the information you need, and as soon as you come back into cell signal or internet, it will submit that report automatically to us. So we hope that that will be helpful in being able to make reporting more accessible to everyone and anyone. And we'll be making an announcement as soon as that becomes available. So thank you for your time and for listening to me, and I'll pass it now back to Janie.
Wow. Thank you. Thank you, Grace. Thank you, Ben. Thank you, Tom. It just is a privilege to work with all of you. Every time I listen to you, I always learn something new, which is pretty incredible considering how much time we spend together. Yeah, so I think it's going to be great now if we can go into a question section here. But before we go that, I think it's really important just to mention that, you know, there's a lot of collaboration and partnerships that have made this work possible. And this is just a couple of photographs of some of the people and a couple of dogs that have really helped us over now 20 years. And, you know, at the moment with this BC hydrophone network project that both Tom and Ben and a number of partners have helped us develop, you know, we are building this interactive user-friendly website that will track different whale species along the entire coast of BC. And this will be overlapped with levels of ocean noise. And, you know, working together, I really believe we can protect whales. We can develop quiet zones for whales and potentially slow down zones for whales. And this site will be live sometime in May, and we'll definitely reach out to everybody here and share that with you. And, you know, that it really, one of the things I've personally recognized, and I think that a lot of people that work with us and as well that are listening here tonight, that have come to recognize that if we really want to protect whales and if we really want to understand whales, then we really do need to listen to whales. And I think with that, if we could go to the last slide, I just really, really, really want to thank, there's been so many people over the years that have supported our work, but there's some, you know, organizations that have been with us from the very beginning. And I think it's really important to always acknowledge those that are there to support you. So with that, I would like to just read out the organizations that have been with us from the very beginning, which is almost 20, it's over 20 years now. And of course, Fisheries, Oceans in Canada have helped us a lot. They've really helped us in regards to the survey work, the drone work that we've done, but as well, they funded this, the development of the species-wide hydrophone network. The Save Our Seas Foundation has been with us almost from the very beginning and have supported us in regards to building the station. The Donner Canadian Foundation has also been with us for now a number of years and has put a lot of support towards the hydrophone network. Of course, the Kitasoo, Hi and the Heiltsuk First Nations have been with us, but the Git-Gat First Nation truly gave us the start. We wouldn't be here today without the Git-Gat First Nation and the Willow Grove Foundation. So they have supported us from the very, very beginning and have been with us through so many different changes. So I really really want to put my thanks out to you, Andy. I hope you're here today. And of course, WWF Canada has really helped us, and just an amazing partnership with Orca Lab and Paul and Helena, because that's for me where it all started. And with that, I think we should open it up to some questions. Um, so I think the best thing to do, I noticed that Grace, you were putting some questions over to the side here. Do you want me to start from there, or should I could just go right into the question section?
I think either works. I think Tom had maybe put some aside as well that he was looking to answer. So I think if we go into the question and answer section, that's great.
Okay, great. Sounds good. I'll just read the question, and I think I'll know exactly who it should go to. I'm just going to start from the very beginning. And the first question is actually from Scott Veers. Thank you, Scott, for being here tonight. He's asking if we expect to hear fin whales within the Salish Sea as they continue to recover on the BC coast. And he's directing it, I think, towards you, Ben, but you want to go for that, and I can go for it as well if you want to.
Oh man, I can't go far with that question, honestly. My knowledge of that is really slim. I know they really like the area up in Squally Channel, and I think from my understanding, it is not 100% clear what exactly drives them into these Gilgit waters and what makes that area special as compared to others. The waters there are really deep, and because it is an extended fjord system, there's a lot of material movement in and out with the tides. But I'm really leaving my expertise here and I just pass it on to Janie about your guesses.
Scott, I would say yes, definitely. I think that I wouldn't be surprised, and I'm surprised you haven't heard them yet, but I am sure that they will be in the area. I mean, there is a lot of vessel traffic that might deter them. Who knows for sure? But I mean, who knew that, a few years ago we all had a sperm whale? So that was pretty remarkable. So I think anything is possible. The next question is from Diana, and we mentioned using a drone, and I'm going to put this one to you, Grace, because you are the drone pilot for BC Whales. And she's asking, what significant observations have you been able to see with this new way of research? And I know you touched on bubble net feeding, but maybe there's a few other things you might want to mention as well.
Yeah, that's a great question. I think that it's just giving us a totally new perspective. So before, where we're looking from a lateral perspective, we're getting photos of whales. Being able to look from the top, we're getting more insight into how they're actually interacting. Social behavior has been huge to investigate with the drone. If whales are just beneath the surface, but they're interacting with each other, that's something we just couldn't see before. And it's really interesting to see what kinds of questions we could start to answer with that. One other thing that I'll just mention quickly is actually with fin whales. And fin whale photo identification has been a struggle historically. We're getting photos of dorsal fins, and often they look really similar. As soon as that drone went in the air, there's a small spot on their back that has a V, and it's called a chevron. And we figured out that, well, us and many other folks have figured out that that's unique. And so being able to ID from the drone is adding a whole new layer to research as well.
Yeah, no, that's great. The next question here, I'll just, this is good. So do transients hunt with other families, and do southern residents hunt only with their own? And if so, could this be why they have a more general dialect so they can communicate between the families more easily for the hunt? And this is from Carrie's Harding Jones. I can answer to that to some degree. Yes, different transient families will hunt together, definitely. And to my knowledge, maybe Grace, you want to take on the southern resident part of that question?
Sure, yeah, I'm flying a little bit blind with that one as well, so take this with a grain of salt, but I do believe that certain families might forage together. I think one way to think about it with orca in general is that they're more likely to be foraging with the whales they're more closely related to, but that's not to say that they couldn't forage with other families. So hopefully that helps to answer that question.
That's good, that's great. This is from Scott Veers. this is about the bubble net feeding calls that we played, and Scott's asking, which of those 3 distinct bubble net feeding sounds is associated with the foraging behavior, or is that whole 9 vocalization sequence you played the indicative sound? And the answer is yes, as far as we know. But what's really interesting, Scott, is how it's changed over time. And I do regret that I didn't play a bubble net feeding call from 20 years ago versus today, because it has changed a lot over time. It's much more specialized in that 500 hertz range at this point, and that beginning part that you heard that I played, a lot of whales no longer use that, which is really interesting. So I hope that answers that, and we can definitely talk in more detail about that. There's another question here from Donna Zierenberg, and she's asking, how can you tell the difference between the song and social calls? I think I could, should I go for that, or does somebody else want to take it? Grace, do you want to take it, or do you want me to do it?
I think you go for it, Janie. You look pretty excited.
Yeah, well, I mean, social calls with humpback whales are just phenomenal. And they do have very specific social calls that they use. They will sometimes use some of those social calls within a song, but in general, those social calls are quite different, and you can tell the difference. And I think the next time we do a presentation, I think it'd be great to put some of these social calls in there. So next time we'll have that in there so you can hear the difference for yourself. Oh, I love this one. As far as the humpback song changing, why do they change? Or could it be that they're just saying something different? I love this. And this is from Trisha. Yeah, Trisha. So Trisha, I can't answer that. I wish I could. We actually are going to be working with a student coming soon. Her name's Erin, and she's going to be helping us. And I think, Erin, you're here. She's going to be helping us to answer these types of questions, because it is something that we really want to better understand. Why is it changing? It's such a great question. At the moment, we don't know. And I almost like that we don't know, but one day we will know. No pressure, Erin. Okay, this is going to be, this is from Diana. Do you feel that with all the noise pollution, the calls that get passed down through family lines will get lost, since calls get muffled in the noise? Tom, do you want to go for that one?
Yeah, well, I can answer a little bit about it. And so there are always times when there are quieter periods and noisy periods. So the whales will be able to talk back and forth at some particular times. And if necessary, they can go around a headland or something if to get it into a quieter area. Whether or not their colleague knows to follow them there in a noisy situation is a different matter. But there will always be times when they can talk back and forth. So I don't think they'll be lost. But you know, that's just a guess from a physicist. I'm not a biologist.
No, I think that's good. I think that's good. This is a question from Bonnie Gretz. Do other rorqual whales have a chameleon tongue? Oh, that is such a great question. I mean, Grace, I can guess at it. Do you want to go for it, or should I do it? Put myself out there.
I'll say one bit, and then Janie, I'll let you take it from there. So I know for humpback whales, at least really recently, a really interesting paper came out that looked at when they're feeding, what happens with their tongue. And their tongue, a little bit different than fin whales. It's not going underneath into that plate. It's actually going backwards and blocking their feeding tube, which I can't think of the word of right now, but it's essentially allowing them to take in that water without inhaling it. So other rorqual whales have really specific adaptations like that. And maybe Janie, you can take it from there.
No, that's what I was going to say. I'm not sure about the blue whale. I'd have to look into it. I think they do. But I did read that about the humpback whale. So a great question. I don't know the answer for other baleen whales, but I do know the blue whale, I think, is quite similar to the fin whale, and then the humpback is a bit different. Oh, here we go. Here you go. This is from Trisha again. How loud is a drone? And how much does it contribute to acoustic fog? That's a good one. I like, yeah, that's a,
So to answer this quickly, a drone is much, much louder in the air than it is in the water. And the reason for that is the sound that's being made by the drone gets bounced off the surface of the water. So very little of the noise that we're hearing above the surface is actually going into the water.
yeah. And then, but just to note, I mean, just so everybody knows that when one of the studies that we do, or one of the protocols that we follow, is, especially when we first started to fly drones, was to see if there was a response from whales. And there are some whales that do respond. We never approach a whale that's in a resting state, for example. But in general, if you stay at a distance, of course, a lot of these drones have a zoom. You can do a lot of work from a distance to collect some pretty incredible data with the use of drones. Okay, next question. I think this is going to be a Ben question, and it's from Steve Brine. I think I'm saying that right. Okay, so it's SETI searches for math patterns. Do you know of anyone using AI ML to search for math patterns in cetacean communication systems, possibly math patterns of math systems unknown to humans?
Yeah, what a question, eh?
Yeah, I know.
Um,
That's why I'm giving it to you, Ben.
yes, I'll answer that pretty quickly from our perspective. And I like the SETI comparison. Maybe what I want to say first is that part of my background is astrophysics, and there's a saying that, the far side of the moon is much better understood than our oceans, and that feeds into that. Where from our perspective, we're working really hard to get to a point to robustly simply detect a whale and classify it. And then obviously a lot of people are going into what does it mean? What do they say? And the math patterns work into that. So from my perspective, I'm not concerned about it, or I simply cannot allow myself to be concerned about it. But as I think someone else commented, there is certainly work done. And I think there's a fairly big active body of research about whale song and exactly the question why it changes and what exactly they're communicating with this. But from my sort of software engineering perspective, I really just want to get the basic statistics and that type of intelligence that's trustworthy out of the ocean.
That's great. Thanks, Ben. And also, I just want to note that Diana noted that a Dr. Denise Herzing is doing this research as well. So, all right, Krista, I love that she put this in here because we didn't mention it. Lone whales bubble net feed as well, and that's true. We do have solo bubble netters, and that's also very interesting when you see a whale that is actually able blowing the bubbles, doing the bubble net feeding call and feeding a surface on its own. Yeah, so that's a great thing to note. Thanks, Krista. All right, Bonnie Gretz. Did the BC humpbacks possibly learn bubble net feeding from Alaskan humpback whales, or is it perhaps a behavior that was learned in both areas about the same time? I saw this near Sitka in 2002. It's a great question. So we have spoken to researchers in Alaska that, of course, have had whales bubble net feeding there for a very, very long time. But a lot of the humpback whales that we've seen are not the same whales that are being seen in Alaska. So we don't know for sure. There could have been the odd individual that interacted somewhere out there and we didn't notice it. It could have been up near Prince Rupert, for example, which is just in between our research area and Alaska. So it is very possible that that did occur. Or did it happen in the same area at the same time? We actually don't know, but it's a great research question. All right. Okay, this is a question from Jeff Reynolds. For some baleen whales, their main source of food are large swarms of krill. Have you picked up discernible sounds coming from large krill swarms? Does the sound fall within the hearing range of baleen whales? And how might boat acoustics interfere with these sounds? So I don't know that we've heard krill, and somebody please correct me. I know that we've heard herring. I think we can hear krill. It's like a snapping sound. So as far as I know, it is within our hearing. And how might boat acoustics interfere with these sounds? Well, that's a great research question. Um, I mean, personally, I would think that it definitely could. I don't know, Tom or Ben, if one of you want to elaborate on that.
Yeah, I can say the boat noise will definitely impact if there's a lot of krill creating clicking sounds in the water, it's going to sound like a buzz. And the boat noise will definitely overshadow that. As Ben was alluding to before, what it's not going to eliminate the sound, but it's going to reduce the detection range of the whales to hear that sound. So they'll have to be a lot closer to the krill swarm if in fact they're using the hearing to localize on those swarms.
Yeah, thanks, Tom. That's great. All right, Grace, this will be a question for you. Are there any preliminary insights on the level of entanglement scarring for fin whales in your study area?
I wish I had a more concrete answer for this. Fin whales we are seeing, and we're studying this as much as we can, but it's a pretty small sample size. So right now, I wouldn't say any level in particular, but just to say that we are seeing evidence of entanglement on fin whales.
But I know that we've just started to dig into that. All right. Ah, here's a good one. Do whales make a specific noise when they sleep? So when whales are sleeping, they actually do not make any noise. They don't make a sound. We've had whales sleeping very close in front of the Fin Island Research Station. So we've watched the behavior and we haven't heard anything. So no, they do not make a sound. And oh, and I like this part too. If whales are speaking at frequencies we cannot hear, are they hearing frequencies we cannot measure? Ben, do you want to go for that one? If you don't want me to say, I can say it again because I should have said.
Repeat the question again.
Yeah, absolutely. So if whales are speaking at frequencies we cannot hear, are they hearing frequencies we cannot measure?
I think taking the question as it is, the answer is no, because the hydrophones can really listen to a lot of frequencies that we can't listen to, but we can make them visible in a spectrogram. So we can go down to 10 hertz, which for us feels like a vibration. And depending on the hydrophone, we can go up to 128 kilohertz, which is the frequencies that I guess bats would use to communicate. Except I'm not a bird specialist or a bat specialist, so I'm not knowing those frequencies in detail. But the hydrophones will pick up pretty much everything that the whales will say, even if we can't listen to it. One of the sort of, in addition to that, an interesting question we have to ask ourselves is, if the whales use a certain frequency range for themselves to be actively communicating, do they hear other frequencies outside of this range, which makes them vulnerable? So if a fin whale, for example, only uses frequencies below 100 hertz, it doesn't mean that it's not disturbed by frequencies that are above this threshold for its own vocalization. So that is an active field of research to find out what their hearing organs can capture and whether or not it starts stressing them.
That's good, yeah. And another part of this question is, how far do we think whales could hear? And I can take part of that. I mean, it depends on the species. So for example, fin whales, because they communicate at such a low frequency, they can probably hear calls from a very long distance, because a low frequency wave can travel much further. And whereas with orca, they tend to vocalize on a higher frequency, that sound may not travel as far underwater as a large baleen whale. But Tom, I think that is maybe something you might want to move.
Yeah, and it
speak to
goes
more.
even deeper than that. So different frequencies are used by different animals, and high frequencies propagate short distances, low frequencies propagate long distances. So you can take it one step further even and look at an orca where it's echolocating to find salmon, for example, or it with really high frequencies, or it's communicating or calling to its companions with lower frequencies. So the calls can travel a lot further than a click that it's using to hunt a salmon. So for a salmon, for example, they're probably looking out to about 200 meters. And that's a pretty rough estimate, by the way. And for the calls, they can go many kilometers. And then for, as I mentioned earlier, fin whales and blue whales can talk over hundreds and potentially thousands of kilometers.
That's great. Thanks, Tom. And those questions were from Rochelle. Those were very good questions. David, oh, it's nice to see that you're here. David Lee Long. Sorry if I didn't pronounce it right. This is for you, Grace. It would be interesting to look at probabilities of collisions based on the speed of a vessel or a boat, so to propose possible mitigation procedures. Yeah.
Yeah, it's a great point, and I will just mention that that's actually being written and submitted for publication by one of our colleagues, Eric Keane. So he's not here tonight, but has done a lot of work relating to that exact question. So that's part of the SWAG project as well. And if you're keen to learn more, there is a SWAG website. So that's swagproject.org, I think. You can find it there.
Great. Thanks, Grace. All right, next question is from Sydney. Have you ever picked up offshore calls on the hydrophone network? So I can't speak for the entire network at this point, but I do know that up in Git-Gat territory, where we've been listening for almost 20 years, we've only heard offshores 3 times so far. And always at night when we couldn't go out in the water and ID them, but we knew they were offshores. So it's exciting when they show up, but it is rare. All right, here's an interesting question from Suli. Can we send drone data footage in real time to alert vessels of relaxing or slow moving whales that cannot be caught, identified at the surface from the public or through hydrophones?
Yeah,
Wow.
it's a great question. It's something that's in the works for acoustics. It's something that Ben and Janie are working on really intensely. With drone footage in particular, I think that you maybe could do it if you were really good at software engineering and all of that. But with drones, the reality is when the drone's in the air, someone's looking through what the drone is seeing. So anytime that drone's flying, I, for example, can see what that drone sees. And if there's a big ship coming in and we're seeing that there's a sleeping whale, we could take action locally and call over the VHF radio and alert them that way, which might be more effective than trying to get an automated alert out. So yeah.
That's a good answer, actually. Yeah, and just, in our particular region as well, we don't have cell coverage, and we don't really have Wi-Fi either, except right at the station. So we have to communicate over the VHF radio, which is not a bad thing when it's vessel to vessel. Yeah, absolutely. I'm going to put this question to you, Tom. It's from Krista Smith. Can I ask why you did not mention military noise, vessel, and explosive impacts? I'm sorry, explosive impacts. Oh my gosh. I need better glasses.
Yeah, I didn't mention it mainly because I only had 15 minutes. So, but yes, it is an issue. Now, there are pros and cons for the military stuff. Military vessels are very quiet, much quiet, hundreds of times quieter than commercial vessels. But the sonar systems, which they are not supposed to turn on in coastal waters, are incredibly noisy and potentially damaging to animals. But in our research areas, we really don't have much in the way of military vessels making loud noises. There are every so often somebody will make a mistake, and it will happen. And people like Scott, who's on the call here, Scott Veers, him and his colleagues, they will pick that up and report it immediately. But in the hydrophone network, we rarely ever see that kind of stuff.
Okay, great. Thanks, Tom. All right. This is from Erin Wall. I'm just going to get to the heart of this. So I think it's going to be a question for you, Ben. Um, okay, I'm thinking also of the work by Whale Seeker using AI to facilitate automatic detection of whales via visualization by drone. Sound makes sense for detecting whales that are under the surface, but I'm curious of your thoughts on the intersection of these innovations.
Yes, I like that question. Because where my vision goes would not be as much to drones, where Grace already put out that it's kind of an awkward situation at the moment to put that into any automated large-scale system. And I think what I would add to this is that the time that we have a drone out and flying is at the moment, it's just a very small fraction of time. But I do really like the concept of using aerial photography or video footage to identify whales on the surface. And I think what at least has been started to become a topic of research is to use satellite imagery, because the cameras on those are really, really good nowadays, which you can see by opening Google Map. And I can tell you, if you roam the coast of BC using Google Maps, you will find whales from that footage alone. So I think this is explored, and I do think it has an interesting potential, with the limitation being the weather, because on cloudy, rainy days, a visual photography will not capture anything on the surface. But I do think the technologies will merge, and I think it is important to highlight that acoustics is not a savior for everything. It has its limitations. Part of its benefits are that you can use it 24/7, and if you automate the processing, you get the analysis for cheap and very quick. But it is obviously limited to actively vocalizing whales, and I do think for areas of concern, you will have in the future a mix of methods that will provide the best picture possible.
Well, that's good. Thanks, Ben. That's great. I just want to say that Tim here is from Tim, and he's made I think he's answering your question from before, Scott, about fin whales. He's saying that they've been in Long Harbor and Prevost Island, and killer whales caught a fin whale in one of those bays near Long Harbor a number of years ago. That might mean more to you, but I think he's referring to your question there. Grace, I'm just wondering, do we have the ability for somebody to just ask a question?
Yeah, if someone puts their hand up, we can give them the ability to speak.
Okay, because Andrew Wright is actually here, and he's actually been a huge funder for us for a really long time, but he has a long question, and I'm just wondering if maybe you'd rather ask it, Andy. There we go. Hi, Andy. Nice to see that you're here. I'm great. I'm so glad you're here.
I'm thrilled to be here. Thank you, guys. Thank you for years of dedicated, awesome work. Thank you. Thank you. To first an observation and then a very strange question, or appears strange. The first about just this, it's lovely to have excellent sort of compaction of 30 years of research into a very nice consolidated package tonight. So kudos to all of you. But in it came this discussion about the dialects of transients and residents, and how that the residents' language is always changing and the transients seems to be more stable. And I just throw out the thought that comparisons with semantic drift in human language, where when language is used fast and furiously and every day, we get this notion of semantic drift very, very quickly. But when transients communicate so much less, the ability or the occasion for slight changes to occur in that language is so much lower. And so semantic drift in that population will be slower by definition, because the number of occurrences of interactions is lower. And that's well documented in human populations and languages. But my main question is, and it might sound like I'm an industry super tanker proponent coming up here, but when Ben was talking about acoustic fog and you know the environment being clouded with noise, I had this notion that what if, because we've had a recovering population, one of the things we've seen in humpbacks is that their population has steadily risen. We haven't seen any population collapses over the last little while. It's been a steady rise. And I got to thinking, is it a metered rise, in the sense that isn't the maximum growth rate that could have occurred? Because on our coast, we've seen herring populations, salmon populations, forage fish populations really be overfished and struggle. Does the noise pollution act like a marine protected area that we've seen around the Galapagos and in Indonesia, where you're not allowed to fish within a certain zone, and so populations of fish recover in that area, and then the outlying areas become very productive for the fishermen. So instead of fishing to complete extraction, you fish to what the outlying zones permit. Does these reservoirs of noise, for want of a better word, provide the space by which the forage fish can actually recover? And therefore the whales are feeding in areas where it is quiet, where the spillover occurs, just like a marine protected area. And it's allowed the population over the last 30 years to actually grow in a steady rate rather than go through a boom bust cycle as they overfeed. And I don't expect an answer, because it's like Andy's smoking crack here or something, right? But you know, the reality is you triggered that thought, and I wondered if there is a space for the thought that industrial corridors could be minimized. So you keep all the noise in one area, and then you allow these quiet zones. But there's actually an advantage in that we will feed the whales by allowing the forage fish a refuge too, created in this noise island, for want of a better word. Anyway, it was a thought for pondering as much as it was a question. So there you go.
I think it's a great research question, Andy. I really do. I can see Tom. I can just see him.
Yep.
It's a phenomenal research question. I think it is a question that should be asked. Could you email that to us?
I've got to remember it now.
Oh, it's
Well,
recorded.
I will add one point in there, if I may, and that is one of the premises that you would really have to address in that research is, what are the impacts on those forage fish and krill? And so if for example the herring, which use sound, so if they struggle in those noisy environments, they may not be able to use them. And I have no idea how krill use sound. That very interesting question.
Yeah.
And just a thought, because you know, I'll shut up because there's other people on the call, and thank you for the privilege of sort of hooking me in like this. But you know, we've just seen in-house sound over the last 5 years, the herring recovery begin to take off, and this is in the Salish Sea on the eastern edge, and so we begin to see humpbacks occasionally around Bowen Island now, right? And I've lived there notionally 20 some years, and it's only just becoming quite frequent, right? You know, so the population is growing and expanding and spreading out. Anyway, you triggered all these thoughts. Great evening. I'll shut up because as Janie knows, I'll talk forever. And thank you for 20 plus dedicated years of awesome work.
Thank you, Andy. Honestly, you've been with us from the beginning, so thank you very much. And we should talk. You should come and meet all these people.
You know, it's on my list of to-dos as I kind of come back out of this COVID shell.
Yeah, no kidding. Well, thanks, Andy. No, that was great, and definitely a good research question. A couple of them, actually. Thank you. Okay, there's a few more here. I know it's getting late, but a lot of people still seem to be here, so we're just going to keep going, and hopefully you can all stay with us. Is whaling still, this is from Anonymous actually, so Is whaling still happening in your study area? Absolutely not. No, I don't. The last year of whaling along the coast of BC, I think was the late 60s. Was it 68 or 69? So no, which is why whales are recovering. And this is okay. Well, this is going to be a question for you, Tom. Is it possible to create devices on vessels that make as little noise as possible as not to harm the fauna?
Yes, and funny enough, going back to the military question a little bit ago, the military, especially the U.S., but militaries all over the world have spent, I would guess, hundreds of billions of dollars to make their warships quiet. And the interesting thing is that over the last couple of years, as noise has come to the forefront of impact on marine animals, those military technologies are being pushed into the civilian world, and we're starting to see those technologies show up on commercial vessels, and even small vessels. There's some really cool new propeller designs out there, and all kinds of little things to help reduce noise coming off vessels. So I think over the next, large ships have a long life, so it'll take a while to cycle through them, but over the next couple of decades, we're going to see huge changes in vessel noise, I think.
Yeah, I think so too. Thanks, Tom. This is from Isabel, and Grace, this is going to be for you. Do you ever help, well, maybe from the two of us, do you ever help an entangled whale you have seen with the drone?
I think that yes is the short answer, but it's the way that we help. And the first thing that we do, of course, is to communicate with DFO, because they are the ones that can actually come out and do a disentanglement at this stage. One thing that we can do is attach a satellite tag when possible to some of the trailing rope, just to make sure we can find that whale again, and that those that can come and disentangle know where that whale is to make that best effort. But it is possible that you see a whale once, and by the time you get your sat tag and you come back, they're gone. So one thing that we're really working on coast-wide right now is developing a communication platform and communicating between regions that we saw a whale entangled here, it was heading in your direction, please keep your eyes out. And that's one thing that we're hoping that our app that we're developing will be able to do. Janie, I don't know if you want to add on to that as well.
No, that was great. Thanks. I don't know if you said it, I might have missed it, but just another note is there's actually been times now that we put the drone in the air and recognized a whale was entangled, and we didn't know it was entangled until we put the drone in the air. From the vessel, from the boat, we actually didn't know. So again, drones are just a phenomenal piece of equipment. This is another question from Sydney. Are you doing any genetic work on your groups of bubble net feeders? Well, this also goes to drones. We do have a PhD student that is working on looking at genetic fingerprints of not just bubble net feeders, but a lot of whales within the community up in Git territory. And what she's doing is she's actually flying the drone through the blow and collecting DNA samples from the drone. It's from the blow itself. And so, yeah, that's a really great project. We didn't talk about it tonight because it's just so much to talk about, but it's a great project. And if you want to know more about it, you can just contact us. All right, this is from Julia Rankin. Oh, this is either going to be a Tom or a Ben question. Does the depth of water impact the level of noise pollution, and do their calls change when vessel noise is present?
Well, I can take the first part.
Yeah, let's do it
yes,
this way.
The depth of the water does have an impact on the propagation of noise, so both on the calls and the noise from the vessels. So in shallow waters, that noise doesn't propagate as far. So that's a help in coastal waters where we're doing our research. So that's one thing. But it also reduces the effective range of the whale calls as well. So both things sort of collapse, and so it's, I'm not sure what the net benefit is going to be there, but that could be modeled.
Yeah, and to the second part, there are shown effects on whale vocalizations based on the noise levels. And I think the one that's best studied and most solidified is called the Lombard effect, which is the simple fact that whales call up when it gets noisier. So they're using louder calls, presumably to overcome the noise levels. But I think there's a couple of at least studies that show evidence that the frequency content is changed, but that's moving on thinner ice and is not as well established. So there's some things where the knowledge is pretty good and they definitely do change things, but the full effect on how whales actively change up their acoustic repertoire is definitely still work in progress.
That's good. Thank you. Thank you both. That's good. Now, Andy, I noticed your hand is up. I don't know. Did you have a question, or I can't tell if. No, his hand went back down. Okay. All right. This is from Krista Smith. Has there been communication with those who study the Atlantic bubblenet feeding humpbacks and your group? And not yet, but I mean, we've certainly have read the papers that have been published, but we haven't actually had communication. And so, Grace, I think we need to follow up on that. That's a good idea, but the short answer is not yet. Okay, this is from Cindy. Oh, thank you for allowing us to access the hydrophones. So that might be referring to Orca Live, which is a part of Orca Lab. And I wish I had mentioned that you can actually go on to Orca Live and through Orca Lab, listen to whales live. She says, I've learned so much listening to whales and it brings me great joy. Do you think we will become advanced enough with sound analysis that we might be able to identify individual whales based on their calls? And I think the short answer to that is yes. I do believe that we will be able to put an acoustic fingerprint to whales. I know that type of work is already in the making. We ourselves personally haven't been doing it, maybe a little bit with humpback bubblenet feeding. When we get a lone individual bubblenet feeding, we can put an acoustic fingerprint to that particular whale. Does anybody want to add anything to that? That was the short answer, but
yeah, there has been some work done on sperm whales for that. You can identify
nice.
the length of the whale based on their interclick spacings in their calls, so you can tell whether it's a juvenile or whether it's a female or if it's a male,
Nice.
based on the size of the whale. So
And there's also
progressing.
some like very exciting work with a group that's I think called Hello Group, and they at least not going into individuals, but they I think started to crunch down on separating the different metro lines and families and pods with the different dialects in an AI system. So that's something that you could look up if that is something you're interested more. But in general, I think I would agree the answer is yes. And something to have in mind also is that with humans, we're pretty close in doing this and separating our different individual voices. But the financial input into those research projects is also immense. Whereas I'm sure there's billions going into voice recognition of humans. We are several orders of magnitude below that. So it's something where we can maybe learn from the big industry eventually.
And just to quickly tag on to that as well, Valeria, who's in this call, has just added that she's working on that work for individual call identification with belugas in the St. Lawrence River.
Nice. Nice, thank you. Okay, this is a question from Carolyn. Is there knowledge of cetaceans communicating more loudly to each other to overcome human noise, as has been measured in some bird species? And I think we might have spoke to that a little bit, but yes, they will communicate more loudly in order to be heard. Ben, was it you that was speaking to that a few minutes ago? I don't know if you want to elaborate on that.
Yeah, I think I won't repeat myself along. The effect is called Lombard effect, and that's something you can Google, and there are several publications out about it. So that's really well documented among different species of whales, actually.
Yeah, no, that's good. Thanks. Thanks, Ben. Um, this is actually pretty interesting because it is something we've talked about and we didn't mention in the presentation, and it's from Mary Morris, and she's mentioning that it seems likely that when the population of humpbacks was so reduced from whaling, that maybe the special sounds that were used for bubble net feeding were also being lost. And now that the population is coming back, whales are relearning how to be successful with complex sounds for successful foraging. And this is something we do talk a lot about, is that, you know, there were so many humpback whales that were taken out of the population. And with that knowledge and tradition and any type of acoustic traditions that were with those older whales that were killed would have not then been shared with the younger whales. So it really is something to think about, is what was actually lost during that time. Yeah, no, I'm just really glad somebody mentioned that because it is really interesting. And she says sharing that learning through their acoustic communication networks, changing their songs and the associated behavior to get better and better at successful feeding, which is what they're doing. Uh, that is what they're doing. So that's great. Oh, this is interesting. This is from Bonnie Gretz. There's a book out by Tom Mustill about communications with whales, and it's called How to Speak Whale. Just heard at a webinar with him. We'll have to Google that. That sounds very interesting. Oh, Grace, this is going to be for you. This is great. It's from Donna Zerenberg. You mentioned whales rolling in kelp. Is that to rid themselves of parasites?
It's a great question. It's one that there isn't really an answer to. It could be part of the reason that they do it. It could be that it feels good. But we are seeing humpbacks just interacting with their environment in general. We mentioned kelp rolling because we see a really clear correlation to entanglement. But one thing that humpbacks are also doing is interacting with logs. So they're going up to logs. They're often sleeping at the surface, sometimes rolling up on them as well. And maybe part of that is for parasite ridding, but we don't actually know. But it's certainly interesting when it happens.
Yeah, yeah. And it's also, just to note, when we talk about kelp rolling, because we see a lot of it up north, but it doesn't seem to happen a lot down south. Now, I would love someone from the Salish Sea or somewhere else to say that that's not true, but people that we have talked to about it, they haven't seen a lot of humpback kelp rolling. So again, it's something that happens more along the north coast for whatever reason, but I hope someone tells me I'm wrong on that one. But I think it does feel really good. They really seem to enjoy doing it anyway. This is from Scott Veers again. This is interesting. Have you heard herring? Well, he's calling it farts, I think, on any of your hydrophones, but it's actually fast repetitive ticks. It's an acronym for it, but it, you know, when you say it. Anyway, we think we've heard these gaseous explosions from the back of little fish once or twice on orca sound hydrophones, but aren't sure. I know that we've heard a lot of herring stuff over the years, and I was told that it is actually gas. But maybe somebody else could speak to that. I don't have a lot of knowledge on that one. No, short answer is yes, we have. Very interesting. Oh, here we go. I've been waiting for this question. This is good. This is from Ken Matheson. During COVID and the drop in cruise ships and marine traffic through Johnstone Strait, was there a change in whale behavior? So I'm not the one to answer that very well. I don't know if Paul or Helena want to come on and answer that, but that is a question that needs to be answered. We certainly did record all whales during that time from Orca Lab, but that is not a question that I would be able to answer. But I don't know, Paul and Helena, if you're there, if you want to step in. If not, Ken, I think that we would reach out to you because that is a project that we are working on, but I just don't have the answer to that question yet. Visually, no, but acoustically, there could very well have been, there could very well be a change. So we'd be looking at data that occurred before COVID. And then of course, yes, during COVID, the cruise ships were not here and now they've come back. So we'd have to be able to take a study and compare those 3 years acoustically to see if there was a change. So I hope that kind of answers the question, but it does need to be answered. Oh, this is a good one. Dwayne Sharman. Do baleen whales use echolocation? So that is a great question. The short answer, we usually say no, but now we're realizing that maybe that's not true. We do get these little call types that I think it was you actually, Tom, that said once you thought it was echolocation. It's not actual echolocation, but the short answer is no, but I don't want to say no completely because I think it's something that needs a little bit more research. And I don't know if any of you want to, Ben or Grace or Tom, want to answer more to that.
I'll just
Well, I can-
elaborate quickly. I'll be quick, Tom.
Yeah, go ahead.
My short answer is in the just taking the meaning of the word, it just means that I use sound and the reflection of sound on any surface for whatever purpose. And I'm pretty convinced that every whale is doing this, whether it's for finding prey or for other reasons, is not answered in that question. But if you take it away from this idea of a killer whale echolocating with clicks, of the more general idea of a whale using sound to bounce it off something and hear it and retrieve an information, I would be pretty sure that every whale is doing that.
Yeah, what we were talking about before, Jeannie, was a hypothesis, but it was proven wrong. So the humpbacks do make this tonal sound with an upsweep or a downsweep at the end, which would be excellent for finding schools of herring, large schools of herring. It would be good for finding the range and the Doppler shift on them so they could tell if they're getting closer to the school or not. And it would eliminate chasing after small herring and only limit them to large herring. But the fact that they were making these calls after they already found them sort of threw that theory out the window. So Jeannie put a kibosh on my hypothesis on that one. But
yeah, but you never say never, right?
Yeah, and certainly there's lots of passive techniques that they can use for finding herring, such as the nodules that are on their on their heads, their particle motion sensors, and they can use those to detect low frequency motions like a fish swimming through the water. So I'm not sure how much research has been done on that, but it's certainly from a physics perspective, a very good sensor for doing it.
Thanks. Those are great responses. Another question. We've got a couple more to go, and then yeah, we've got a few more to go. It'd be nice to get through all of them. I think a lot of people. I see some people are starting to leave, but I'll keep going. And if you have to go, I just want to say thank you before you go. But we will just do a few more questions here. This is from Devin Whitmire. Do whales vocally respond to local noise pollution, loud events, and other human-made sounds, not just shouting over the din, so to speak, but react directly at boats, construction, and other such things? So, we are asked this question a lot, and one of the things about whales is that a lot of the behavior that we don't see is happening under the water. So they could very well be having a physical reaction to sound, but we don't see it because we can't see underwater at all times when whales are in the area. So it is a hard question for us to answer. As well, unlike ourselves, we have all kinds of facial expression. Whales do not have that as well. So it's harder for us to answer that question. But do they sometimes react physically with robust behavior like reaching, etc.? Yes, but can we totally say, well, that's because of what just happened? Not necessarily. It is a really difficult question to answer, but definitely a question that needs to be answered. And I don't know if anyone else wants to speak to that.
I think you covered it well.
I was just going to say, I think the best way for us to answer it is through acoustics, because that's the one thing that we can actually measure. But hopefully over time, and again with drones, we may end up finding more answers to that question by using drones and looking at surface behavior of whales. I think that'll make a difference. Next question, how can we differentiate between the sound of a whale and a dolphin? So they do sound very different, and I apologize that we don't have dolphin sounds, but dolphins, can anybody imitate a dolphin? They're they talk really fast, or they vocalize very quickly.
I kind of think of them as the mice of the, like squeaking mice in the ocean myself,
They're
but
very,
uh,
very chatty, and yeah, like a
yeah.
large flock of birds talking at hyperspeed. But again, so we can tell the difference. Yes, you can definitely tell the difference.
And along that note, a lot of different species use different frequencies. So like a porpoise is up over 100 kilohertz in some of their click users. And dolphins are really high, but not as high as porpoise. And orca are part of the dolphin family, actually, but they use high frequencies, but not as high as the other dolphins. And so there's a lot of separation from one species to the other, just in the frequency band that they use.
That's actually good. Thanks, Tom. I'm sure everybody can see the chat, but there's just a nice link here from Scott. Here's a sonar chronology for the Orca Sound Hydrophone Network in Washington. And so, yeah, if anybody wants to Google that or click that on, that's great. Thank you. And Tim, oh, this is interesting. So we are purchasing shower props that are said to be,
Cheryl.
thanks, Tom. Can you read that, Tom? That's a thing for you there. Can you see that one?
Yeah, so we're purchasing Cheryl props that are said to be more efficient energy-wise and also said to be much quieter, hence our experimental purchase, so to speak. Are there other potentially beneficial technologies that we should be looking into either support or test? This is not an endorsement of Cheryl, just a question around the need to push for improvements in technology. Yeah, so there's a lot of stuff coming down the pipe. They're like Arneson drives or surface piercing propellers, and they're supposedly quieter. I've never actually measured one. It's cool, Tim, that you're getting some Sheros in, because I desperately would like to do some sound measurements on those. So if you could drive over one of our hydrophones now and again, and give me the GPS track for your boat when you do it, I would love to get my hands on that data so I can see just how good they are. Because I have seen some pretty cool stuff coming out about those props. And there are other technologies like boss cap hub fins and all kinds of different things that you can do. One of the best things that everybody can do is clean the bottom of your boat. That creates a lot of turbulence. That turbulence goes into the propeller, and that propeller is going to make a lot more noise. And turning your rudder, all the propeller wash going over that rudder creates a huge amount of noise. So yeah, there's lots of technologies coming out, and which is great, but there are other things you can do just by cleaning your boat.
Well, thanks, Tom, and thanks, Tim, for bringing that up. That's great. We have another question here from David. Are there emerging possible signs that some vocalizations are used as name tags in different humpback whales? Not to my knowledge as of yet, but what a great idea to think of it in that term. But no, not to our knowledge as of yet. And he's also mentioning that B&F bubble nut feeding seems to be appearing along the European coast. So that's really good information. Oh, that's where you've said that. Oh, and Andy Wright is just saying that kelp forests have collapsed in the south due to ocean warming. So maybe that's why we're not seeing a lot of kelp rolling. But then Sydney is saying there is some kelp rolling that is happening in the Salish Sea. So that's wonderful. Thank you for sharing that. That's actually really good to hear. Usually around Race Rocks. Okay, that's wonderful.
Sydney, if you ever see that and feel like reaching out to us, we'd love to hear about what's going on with kelp rolling down there.
Yeah, absolutely. And Andy's also mentioning that he's heard some humpbacks bellowing when they are being hassled by a gang of sea lions. That's actually true. They do like that big tonal blow. Oh, that's great. Um, oh boy, I think that was amazing. Those were so many great questions. So we are at the end of the questions, and I think this has just been phenomenal. Thank you everybody for being so engaged and just asking these incredible questions. I just want to thank you, Grace, Ben, and Tom. You have made this work. It's just a delight to work with you, but you've really brought your own vision to BC Wales, and I just really, really appreciate it. And thank you for sharing your knowledge with everybody here tonight. And thank you, everybody. 9:30. Wow. Thank you so much. And I guess this would be a good time. I'll say good night, and maybe everybody else, Grace, Tom, and Ben, if you also would like to say good night.
Yeah, I'll say goodnight, but I'd also like to thank you, Janie, for leading us through all of these last few years. It's been great.
Thanks, Tom.
Yeah, thanks everyone for joining us, and for those that stuck around for all the questions. We really appreciate that. And if you're keen to learn more, please reach out to us on social media. I think Janie's email was up there as well. We're keen to keep the conversation going and talk more about whales and how to protect them.
Yeah, I can only echo that. Thanks a lot to everyone. I'm very impressed. There's still 55 people here because I'm really folding in front of the camera. So means apparently there is an interesting topic, and it's great for you to stick around that long.
Yeah, absolutely. And yes, if you want to reach out, it's bcwales.org, and we're here to answer any questions at any time. So good night, everybody, and thank you so much for thinking about whales. Bye-bye.